Hello guys, today we consider a problem with a particle that is moving in two dimensions. Particle moving in two dimensions, so which means the particle has a coordinate along x-axis and also along y-axis. Okay, let's consider this problem. Says a particle's velocity is described by the function which is v along x-axis equal to t squared minus 70 plus 10 meters per second, where t is time in seconds. So 4.1, they say at what time does the particle reach its turning point? Okay, that is, let's work out that one. Okay. All right, so we have this function here where v is equal to t squared minus 7t plus 10. So at the turning point, of course, the velocity should be 0 because an object cannot, or a particle cannot turn without stopping. Okay, so velocity here is 0. So say this must be 0. Okay, so which means we have t squared minus 7t plus 10 equal to 0. Then we can factorize this. Okay, so we're going to have t and t. Factors of 10 is 2 and 5. So the factors that will also give the middle term here, the term of t. So which means t is equal to 2 seconds, or t is equal to 5 seconds. Okay, let's write end here. Okay, that was 4.1. Yeah, values of time at the turning point. Okay, 4.2. Let's check what we're supposed to calculate for 4.2. Okay, what is the particle's velocity at each of the turning point? Okay, that is 4.2. So what are we looking for here? Acceleration at the turning point. So what we need to do, first of all, we work out the acceleration, which is the derivative of velocity with respect to time. So let's derive this becomes 2t, and this becomes 7. Derivative of 10 is 0. Okay, so this is acceleration. Now let's work it out. Okay, when t is equal to 2 seconds, let's work it out. When t is equal to 2 seconds, so we substitute ax is equal to 2t minus 7, so which is 2 times 2 seconds minus 7. This will be the same as negative 3 meters per second squared. Okay, that is A. Let's check now. When t is equal to 5 seconds, then ax will be 2 times 5 seconds minus 7, which is 10 minus 7, which is 3 meters per second squared. Okay, so as you can see here, we have two different values of acceleration, which means acceleration is not constant. So which means we cannot be able to use equations of motions. Here we can use only the derivative to work out acceleration. Okay, so I mean it's also clear, as you can see, the acceleration, the function of acceleration there is written, as a function of time. So which means it changes with respect to time. Next question. Okay, 4.3. At what time is a particle moving at a constant speed? Okay, so constant speed, which means acceleration is 0. Okay, so we have 4.3. So ax is equal to 0, which means the derivative of a velocity, the rate of change of velocity is 0. So we're going to have 2t minus 7 equal to 0, which means t is equal to positive 7 over 2 seconds. Okay, which is the same as 3.5 seconds. Okay, let's write it as decimal fraction. So this is 3.5 seconds. Okay, let's go now to the next question. And calculate the position of the particle after 2 seconds. Okay. Position, that is 4.4. Okay, so if we're given the function of velocity, so to work out the position, we need to integrate. Of course, it's gonna be from 0 to time, which is from 0 to just 2 seconds, right? Vx dx we derive with respect to time, which is the initial position plus the integral from 0 to 2. Okay, so what was the time? Right? The particle starts moving from e over 3 minus 2 to the power 2 is 4. Okay, 4 divided by 2 is 2, 2 times 7 is negative 14. 10 times 2 is 20. Yeah, so what is the answer here? 8 over 3 minus 14 plus 20. 8.67 meters. That is the position of the particle after 2 seconds. Okay, let's check the next question, 4.5. Write as a vector notation after 2 seconds the position of the particle. It is 4.1. So 4.5.2, the velocity of the particle, 4.5.3, and the acceleration of the particle. Everything calculate as, we work it out as a vector notation. So we need to indicate whether it's moving towards y-axis or x-axis. Okay, so 4.5.1, that is a position. So we worked out the position already. So here, how much did we get? We got x equal to 8.67 meters. along x-axis, which is denoted by I for x-axis. Then after 2 seconds, we say the particle is at the turning point. So which means, okay, sometimes we use this to indicate that this is a vector. So this will be 0 meters per second because after 2 seconds, the particle is at the turning point. There's I there to show that this along x-axis, that is B. Then the last one, acceleration. Okay, what is the acceleration? Remember we said after 2 seconds it was negative 3 meters per second. After 5 seconds it was positive 3 meters per second. So this one we write it as follows. You can just put negative here. 3 meters per second squared along y-axis. Okay, so this is how we solve this type of questions. Okay, let's check this. Do this one by yourself. Let me know if you experience some challenges. Particle is moving according to the following coordinates of position in meters as a function of time in seconds. Okay, so the coordinates along x-axis, coordinates of the position along x-axis is negative 0,6 t squared plus 14t plus 28. Along y-axis is y equal to 0,4 t squared minus 18t plus 8. So the first question is, what is the particle's position as a vector notation at 5 seconds? 4.2, calculate the magnitude and direction of the position. 4.3, calculate the x component of the velocity at 5 seconds. 4.4, determine whether the acceleration of the particle is constant along x-axis. Okay, please do that by yourself. Okay, yeah, that is the end of the activity. Okay.